academic, Thursday, April 6th, we're doing the 9-3 notes, the first day of them. Okay? We're going to talk about what's called exponential functions, right? So, right, in Algebra 1, the first type of function you guys learned about in Algebra 1, right, that was called linear functions, right? What kind of shape did linear functions have? What's a line look like? Just a line, yeah. Just look like that, right? Or it could look like that, right? Okay. So that's a linear function, right? That was like y equals mx plus b, right? Okay. And then, toward the end of Algebra 1, you learned about what kind of function? What's that? Parabola. Yep, you learned about quadratic functions, right? Right? That looked like what? Like a U, right? And that was what? Y equals ax squared plus bx plus c. You learned about another one in Algebra 1. Absolute value function, right? Right? That looks like a V. Okay? Today, we are adding to that list of functions that you have learned about. We're going to talk about what's called an exponential function, okay? Okay? We're talking about what's called exponential. Okay? So in these two, right, x was just one of like the variables in the equation, right? It was like a number, right? It was just like a regular multiplied m or multiplied a. You squared it maybe, right? We've learned about polynomials. You might cube x. What's different about exponential function is now x is going to be part of the exponent. So exponential growth functions, they actually, for both of them, the equation just look, this is the parent function. It looks like this. B to the x, some number raised to the x. Now your x is part of your exponent for the first time. For the first time in forever. X is in the exponent, okay? Okay? So there are going to be two cases here, okay? Two types of parent functions, okay? Both of them are going to have what's called a horizontal asymptote through y equals 0. Okay? Okay, so if this number b here, if b is greater than 1, it's going to be called an exponential growth. Okay, and what that looks like, it's just going to look like a swoosh, an upward swoosh. Okay, so it starts really close to my asymptote, and then it goes whoosh. Okay, that's going to be an exponential growth. Okay, I'll pan the camera a little bit because there's a horrible glare. So this is an exponential growth. Okay. Right. If b is less than 1, if b is like a fraction that's less than 1, it's going to be called exponential decay. Okay? It's the exact same thing as the growth function, but backwards. It's a downward swoosh. Okay? That's like what a graph of that looks like in general. It looks like a swoosh. Now it's going to change, right? But it can flip or shift around when we add and multiply by stuff, or stretch and compress. But in general, those are the most basic. This is the most basic exponential functions. Okay. So b is greater than 1, the function is an exponential growth. I don't know what they want me to write for that next one. So we're just going to do it my way. B is less than 1, the function is an exponential decay. Right. Parent function is f of x equals b to the x. Okay. asymptote is y equals 0 for the parent functions, okay? So step 1 for graphing this one, you're going to classify as growth or decay. Bless you. You're welcome. Okay, you're going to classify it as growth or decay. You're going to plot the asymptote. And then you're going to plot 2 points. You're going to plot 0, comma f of 0. That's the that's the y-intercept, and 1, comma f of 1. And then step 4, you're going to draw your swoosh. Okay, step 4, you're going to draw your swoosh. You're going to draw your swoosh. And then we'll graph it first, and then we'll fill in all these spaces, okay? So just bear with me. Thank you. Please and thank you. Man. Yeah. Right here. Okay. So those are 4 steps for parent functions, okay? And we these to the left a little bit. I don't know what to do. Alright, just let me know when you guys are done writing the steps. I need some space to do the problem. I need space. Oh, I'm so sorry. Right. Okay, can I do the problem? Okay. Yay, stats. Okay, I'll just shrink that. Right. So let's classify this as a growth or decay. Is this going to be a growth or decay? How do we know? It's a growth. How do we know? Because that number is greater than 1. Right? We know it's an exponential function because x is in the exponent, and we know it's a growth because x is greater than, or because that number next to x, that we raise by x, that's greater than 1. Okay, so it's going to be a growth. What do we know then about the shape of the swoosh? It's going to be a growth. It's going to be upward swoosh. Let's plot the asymptote. What's the asymptote going to be here? So hint, unless you have something added, if you don't have that, it's just going to be y equals 0, yeah? Let's plot that guy. Asymptote is y equals 0. Okay, so the line y equals 0, let's do this as a dashed line. That's that. Okay, let's plot these 2 points. So, okay, plot. Okay, 0, comma, what's f of 0 going to be? F of 0, right? I plug in 0 for x. What's 2 to the 0? 1, right? And notice, guys, since the x coordinate is 0, that's my y-intercept. Okay. And then if I plot 1, comma, what's f of 1 going to be? Yeah, 2 to the 1, which is equal to 2. So let's plot those 2 points, 0, comma 1, 1, comma 2. And then again, if you got the first part wrong and you thought it was an exponential decay at this point, this should be setting off red flags, right? Because you have, since this goes like up, you have to draw an upward swoosh. Upward swoosh. There you go. That's it. Okay, so then we can fill out the spaces on the right. So the domain, what's the farthest to the left this graph goes? Negative infinity. To the right? Yeah, it's like a diagonal line. Okay, range, what's the farthest down this graph goes? 0, right? Is that 0 going to get a parenthesis or a bracket? Why are we thinking bracket? So Okay, this is a little tricky, okay, a little crafty. So asymptote, that word means that the graph gets really close to the line, never actually touches it. So it should get a parenthesis. Okay. So 0, and then what's the highest up it goes? Okay. End behavior says this means as we go to the left forever, f of x goes to where? So as x goes to the left, y goes where? So let's trace along our graph. As we go to the left, where's my y getting close to? 0. Yes, that's going to be 0. I never really explained that notation. Sorry, that's to the right. I'm so sorry. Let's just flip these. Sorry. There we go. There you go. Fix that. Right, x going to negative infinity is to the left. Sorry about that. If x goes to positive infinity, that's as we go to the right. So as we go to the right forever, where's my y going? Go to the right forever along my graph. Where's my y going? And going up forever. Okay. Y-intercept, just copy that down. Asymptote, copy that down. Okay. You good? All right. For this next one, can I move on? So let's identify this. Is this going to be growth or decay? Growth. It's going to be growth. Okay. So upwards. Okay, guys. Literally everything's going to be the exact same except for one point. So I'm going to go ahead and be lazy. Just copy this. All right. There you go. There you go. The only thing that's going to change, is this point here. Okay, what do I get when I plug in 1 to this function? 3. Get 3. So that's going to be 1, 3. That's the only thing that changes. So it just curves up a little faster. That's the only thing that changes. So I'm going to be lazy and just copy and paste. They don't pay me to rewrite everything. One salary, so. It's very similar. It's not the exact same, right? Because that point, I'll highlight for you. These 2 points here are different. This one is just a little steeper. It's just a little. The bottom one is just a little steeper of a swoosh. Does that make sense? Yeah. Yeah. It's just gonna grow faster. Okay. Can I move on or not? One more second. Okay, 1. All right, same thing down here. Same 4 steps down here, okay? So this is going to be a decay. All right. How do I know it's a decay? The number there is less than 1. So what's my swoosh going to look like? Yeah. So it's going to be a downward swoosh. Okay. Downward swoosh. Okay. asymptote is going to be what? It's going to be y equals 0. Okay, so let's plot that. Okay, and then f of, so then yeah, so 0 comma, what's f of 0 equal to? 1. F of 1 is what? Yeah. Right, because 1/2 to the 1 is equal to 1. Okay. Let's plot those 2 points, 0, 1, 1, 1/2. All right, so it's going down now. Okay. So our swoosh is going to go down. Domain right goes to the left and right forever. Okay, the range is going to be the same, right? The lowest it gets, the lowest my orange graph gets is 0 with a parenthesis. The highest it gets is infinity. Okay. End behavior is going to be a little different, right? So for that first line, what should I write down right here? So as x goes to the right forever, where's my y going? 0. And as x goes to the left forever, where's my y going? Okay. Y-intercept, just copy down the point with 0 as its x coordinate. Okay. Asymptote is y equals 0. All right, can I move on? All right, what do you think I'm about to do for this next one? Copy and paste, right? Because is this a growth or decay down here? Decay, yep. It's decay. Only thing, oh shoot. Only thing that's going to change is what? So just the 1 point, right? What's f of 1 now? F of 1 is 2/3. Okay, so instead of this being at 1/2, it just needs to be at 2/3. So it's going to decay a little slower. It'll be a little less steep. Right? Yeah.
What's the 1/2 for?
Sorry. Yeah. That was, I copied that down. Right? Up here I showed that 1/2 to the 1 for this one was 1/2. Now, down here, f of 1 is 2/3 to the 1, which is 2/3. Alright, can I move on to 5? Alright, I'm going to just brush over 5 in the interest of time. This one can be a little tricky. Is this a growth or a decay? Growth. Why is it a growth? Yeah, so 5/2, it's a growth. since 5/2 is greater than 1. Okay, so just because it's a fraction does not mean it's less than 1. So be careful on a test or quiz. Don't just see the fraction and write something down and then keep going. Flex. Okay, so then it would look just like one of these exponential growth graphs. Okay, does that make sense? All right, so I'm just going to brush over that in this for the interest of time, because I think this next topic's a little tougher. Okay. All right. So these are really basic. These are really basic exponential function graphs. Okay. This next part, this is what the homework's over. These are not basic. Look at that parent function. That is not basic, right? So I'll show you guys something, right? So we have, right, we have that initial, it looks like our parent functions, right? But then it's got all that extra jump, okay? Right? H is the, so what's going to happen here, okay? If you have, man, I'm tired. I'm tired and hungry. I'm getting angry. So if I have f of x equals b to the x here, okay, and I add in an h, or I subtract an h, that plus that's inside my exponent, the plus or minus that's inside my exponent, is going to shift my graph left or right. Okay? So h is the horizontal shift. Okay, a plus h shifts it to the left, it's backwards. Minus h shifts it to the right, okay, k. So if I take my parent function and I add a k outside the exponent, or I subtract a k outside the exponent, that's going to shift my graph and my asymptote up and down. Okay, plus, this is the same now. It's not backwards. A plus makes it go up, a minus makes it go down. Okay, this is both the graph and the asymptote are going to shift. Okay. If I take this parent graph, right, and I add like a negative in front, or a -2 or something like that, what do you think that's going to do? It's going to reflect it. It's going to flip it. It's going to flip it vertically. Function is flipped across the I'm not going to say the axis, it's flipped across the asymptote. Okay, and then if my absolute value of this number in front is greater than 1, it's going to stretch the graph. Absolute value below 1 will compress it. I can move on. Okay. Right? So the parent function, it says identify the parent function. That's just going to be the x and the number right next to it. Right, so let's call that p of x. So what would p of x be here? So we're just going to keep x and then the number that's right next to it. So the parent function is just 3bx. Okay? Now, f of x is just going to be what? It's the same as p of x, but where does it move? Where does the graph move? What is that plus 5 outside my exponent do? It's going to shift up 5, but shift it up 5. Asymptote as well. Asymptote gets shifted up 5. Okay? The asymptote is actually, I'm going to highlight that in blue. The asymptote is always going to be asymptote is y equals the blue number. Always that. Next one, what's my parent function going to be? One over 4 and then raised to the x. Okay. Now what? We have a little bit. What are the two extra things here? We have that 2 in front and that minus 1. Okay. So what's that minus 1 going to do? Notice that that minus 1 is in the exponent. Do you guys know what I mean by that? Like it's part of the exponent? What's that minus 1 going to do to my graph? Shift right 1. Okay. What's that multiply by 2 going to do? The absolute value of 2 is greater than 1. So it's going to stretch it. No. No, Sean Carter. Okay, and then will that 2 flip my graph across the asymptote? Why not? It's not negative, it's positive. Okay, all right, good stuff. Let's do this one. Okay, so what's my parent function? Ignore the negative. It's just that's a good question. It's just going to be positive 4/3. So just the number that's right next to it. Treat the negative as like its own thing. So it's just going to be 4/3 to the x. Okay. Right? And the extra stuff, all the extra stuff there, that negative, that +2, that +7. Okay. What's the let's talk about this. What's the +7 outside my exponent going to do? It's going to shift up 7. And then what's my asymptote going to be? What's the equation of my asymptote? Y equals 7. Just y equals whatever that outside plus or minus number is. Four thirds of the x is the parent. Yeah, that's one of the answers. Yeah, that's the first part. This answer then, the answer for the second part is like these little descriptions. that plus 2 inside my exponents, what's that going to do to the graph?
Shift to the left.
Shift it to the left by 2. Okay. And then that negative, is that going to stretch or compress the graph at all? Absolute value is just 1, so it's not going to stretch or compress it. It is going to do what? Flip it across asymptote. Okay. And then I'm going to have to move on for the sake of the interest of time.
Just describing what the thing is doing is the answer.
Yeah, that's the answer. So your answer would be all these descriptions. It'd be the parent function, then it'd be shift up 7, shift left 2, flip across asymptote. You'll have that in pre-cal a lot next year. Okay, can I move on? I'm going to go on to 5. Okay, so now we're going to graph these a little more complicated ones, right? Okay. So the first thing you're going to do, the first step for these is you're going to plot the parent graph. These 4 steps we talked about above, right? Okay, so the parent graph, what's the parent graph here? 2 to the x, right? So I'll have 0, 1, 1, 2, a little asymptote in there. Plot the parent graph, okay? And then write down your transformations. So what's happening here? That plus 5 inside my exponent is going to do what to my graph? What does a plus 5 inside my exponent do? Shift left 5, okay? Okay. So then apply, what you need to do is you need to apply your transformations to your points in your asymptote. Can't shift your asymptote to the left, so it's just going to be the same line. Okay. And then, but those 2 points, you guys see those 2 pink points? I'm just going to move both of those to the left 5. And then draw your new swoosh is the last thing. There you go. Okay, and then you can write down all the information. So I'm going to whip through the information real quick. What's my intercept? The y-intercept's going to be a little different. What's that going to be? 0, 1. What's f of 0 here? 32. Okay, so to find the y-intercept, you always plug in 0 for x. And asymptote is y equals 0. Okay, can I move on to the next one? Alright, in the interest of time, I gotta move on. Or else I have to do your homework. Okay. So 6, what's the parent graph? 1/3 of the x, right? Is that a growth or decay? Okay. So let's plot that parent graph, okay? So I'm going to plot 0, 1, 1 comma 1/3. I'm doing that kind of fast just in the interest of time. Plot the asymptote. Graph, okay? And then what are my transformations going to be? How does this f of x differ from p of x? What did that minus 2 do? That's a minus 2 that's multiplied by. What did the subtracting 2 do? Right. Shift it down 2. Right. It shifts down 2, right? Because it's a minus 2 outside the exponent. If it were a minus 2 inside the exponent, that would have taken me to the right. But since it's outside the exponent, I go down. And again, it's not a flip because it's not a times negative 2, it's just a minus 2. Okay? So shift down 2, okay? So we're going to take my asymptote, okay? Shift it down 2. What's the equation of my new asymptote going to be? Y equals negative 2. Good job. Okay? And I'm going to take those 2 pink points and shift them down 2. Draw my new swoosh. The asymptote is y equals negative 2. The range is going to be a little different now. What's the highest it goes and the lowest it goes? What's the lowest we go now? So what's the lowest that y goes? Negative 2, and then it's still up to infinity. Okay. Y-intercept. What do I get when I plug in 0 for x? What's f of 0 going to be? What's that? It's going to be negative 1, okay? So 0 comma negative 1. Can I move on to 9? Can I skip down to 9 so I can show you a flipping one? Okay, I'm going to move on to 9. Number 9. Okay? Number 9. Okay? So what's my parent graph? What's p of x? 4 to the x, right? Is that a growth or a decay? Growth, okay? So that's a simple one, right? Let's plot the asymptotes. Okay. Let's plot those 2 points, 0, 1. 4. Okay. How does that parent graph get transformed? What does that -2 inside the exponent do? It inside the exponent. Right. The minus 2 outside is going to flip it. The minus 2 inside of it is going to shift right 2. Okay. And then that negative 2, that's going to flip it, flip over asymptote. Okay, and then that, because it's negative 2, what's the 2 going to do? Vertical stretch. Okay. So let's apply those to our asymptote and our 2 points. The asymptote can only get shifted up and down. That's the only thing that can change it. Is there an up or down shift here? No, so it's just going to stay the same. Okay. But then we got to take those 2 points here, right? We got to shift them to the right 2, and then we got to flip them over the asymptote, okay? It's going to go 2 to the right, but then it's going to flip over the asymptote. You guys see that? Same thing here. This one's going to go 2 to the right, and then it's going to flip over the asymptote. You guys see that? Over the asymptote. All right? And then draw your new swoosh.
Do we need to worry about like a vertical stretch all showing that or
Don't worry too much about that. I'm not going to die on that hill right now. Domain is all reals. What's the range going to be? What's the highest this goes? It has a ceiling now, right? 0 goes all the way down to negative infinity. Okay. Y-intercept is going to be negative 2 times 4 to 0 minus 2. I do that worksheet for Tuesday.
But I think I don't want to do it all.
Yeah, I do that worksheet for Tuesday.
I don't want to do it all.
The worksheet for Tuesday. Good work today.